Good morning. My name is Darryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. I'd like to take a few minutes and show you how to connect one of the new 5,000 ohm strain gauges into our P3 strain indicator. You've got a couple of different options. One option is to use these standard S-type resistors. This one happens to be a 5,000 ohm resistance. And we can combine that with the strain gauge and connect it into the P3 as a half-bridge circuit. Another option we've got are these bridge completion modules. These bridge completion modules, these are an MRF 50C-130, and that bridge completion module would actually present a full bridge into the P3. Now for this exercise, what I'm going to use is one of the 5,000 ohm resistors. And I've just taken one and added a couple of pigtail wires onto it just to make the connection a little bit easier on the P3. But if you want to, you could go directly with the leads off the resistor right into these connections on the P3. Now the input that I'm going to use is the beam that Ben installed a couple of gauges on it. The one that's on the left-hand side is a 350 ohm strain gauge, and the one that's on the right-hand side is a 5,000 ohm strain gauge. And what I want to do is take a few minutes and just show you how to connect this into a standard P3 strain indicator. It's pretty simple and pretty easy, but I want to show you. So the first thing we're going to do is connect the 350 ohm strain gauge into the P3, and we've got a 3-wire quarter bridge. Just to review, the red conductor for us typically is the P+ connection. That one's by itself. White is typically S-. Black for this connection is going to be a D350 connection. And just as a reminder, the black and the white wires, they are common together out at the tab on the strain gauge. So all I'm going to do is take the red conductor, feed that into P+, take the white conductor, connect that into S-. And then the black conductor, I'm going to connect that down to the D350. Pretty simple, pretty easy for that 350 ohm strain gauge. And it's quite simple and easy for the 5,000 ohm gauge too. You just need to provide an additional 5,000 ohms of resistance to be able to balance against it. And that is going to be this resistor that I just showed you. So for this connection, I'm just going to connect it on to channel 2. The red conductor is going to go into P+, and then the white conductor is going to be S-, and I'm going to common that into one of the wires on the resistor. It doesn't really matter which one. I'm just going to use the red one. I'll twist them together. I'll connect that into S-, and then now we're going to connect this black conductor. This one is actually going to be connected into P-. So now as you look at the front of the instrument, you've got the 350 ohm gauge connected on this side, you've got the 5,000 ohm gauge connected on that side along with the 5,000 ohm resistor. So now we will turn this on and see if we can set it up. First thing you want to do is obviously turn on the power. This is a battery powered box. I'm going to activate the channels, and what I'm going to do is activate channels 1 and 2 and turn off 3 and 4 because I don't really need them. So I've got channels 1 and 2 active, 3 and 4 are off. I'm going to set the bridge type, and I'm going to leave these both set at quarter bridge configurations. I'll just menu to get back out. And now I'm going to set the gauge factor. And if you look on the engineering data that comes with the strain gauges, you'll see that you've got gauge factor information for the strain gauges. And for the 350 ohm gauge, the gauge factor is 1.95, so I'll set that. So I push the gauge factor button. I'll go down and across. And 1.95, and again I'll menu to get back out. I'll go up, I'll go over to channel number 2, which is the 5,000 ohm gauge. And for the 5,000 ohm strain gauge, the gauge factor is 2.04. So I'll dial that into the instrument as well. So I'll just arrow down and go across and menu to get back out. So far we've activated the 2 channels, we've set the bridge type, and we've also done the scaling or setting the gauge factor for the instrument. Really the next thing to do is essentially balance it. So what I'm going to do is just take this beam and slide it into this small fixture. And this fixture will just hold the beam and allow me to put a weight on it. So I'll just slide it in like that, simple and easy enough. And right now it's got its own weight just from the weight of the beam. So again, I've got a little bit of an offset due to the weight of the beam as well as the offset from the gauges. But right now we're at an unloaded state. So what I'm going to do is press this balance button. And what this is going to do is adjust the offsets and provide a good 0. I'll save that setup. And now if I push on the end of the beam, you can see the outputs change. If I let it go, you can see them return to 0. And if I go ahead and put a weight on the end of it, try to get it in about the center of the beam. If I take this P3 and turn it up so that you can see it, both gauges are indicating about the same thing. They're oscillating a little bit, but they're right about 480 microstrain, give or take a couple of counts. So to summarize, the 2 gauges, one 350, one 5,000, bonded onto an aluminum beam, connected into a P3 strain indicator. The only thing I've had to do in addition to a standard P3 is just add a 5,000 ohm resistor. And you can do that directly on the front panel. I put pigtails on it thinking it would make it a little easier, but you can take that resistor and connect it right here at the front. And it's very simple, very easy to set this up. If you'd like to find out more about these 5,000 ohm strain gauges or the 5,000 ohm resistors or the bridge completion modules, please feel free to take a look at our website at www.micro-measurements.com or give us a call at 919-365-3800 and follow the prompts till you get to applications engineering, and we'd be glad to answer any questions for you. Thank you.